Welcome everyone to this technical preview of variability in MontiArc. First, we will look into the modeling aspects of variability. Hierarchical variability in MontiArc is based on parameters. It works similar to conditional compilation as the variability is applied before simulation, runtime, or code generation. Variability introduces three elements into components: if-else statements, constraints, and features. Features are just a new form of parameters and act exactly like Boolean parameters would. They only differ in how they are assigned, as they can be considered named and unordered parameters. If statements introduce optional elements into components based on Boolean expressions. The expression can contain parameters and constants. However, all have to be bound before runtime. If statements can be nested and contain elements like ports, connectors, and subcomponents. Constraints allow to specify what parameter bindings are considered valid and limit the possible configurations. Internally, variable components are modeled as 150% models. All optional symbols are added to the scope of the component and are filtered out when needed. To keep track of what symbols are optional, the variation tree is used. It has a node for every if statement, containing its condition and pointing to all comprised elements. The implementation can be found in the variable-arc variation point class, and the variation tree is built by the variable-arc janitor. The scope now has additional name-resolving methods, accepting a set of variation points, and only symbols contained inside these, or at the component's root, are considered at name resolution. When we look at a component instance, we want to derive the set of variation points corresponding to it. A simple traverser in combination with an expression solver is used to derive a variant. Whenever it is not possible to solve a variation points condition, we assume the variation point to be included in the variant. This is, for example, the case when parameters are bound to other, not yet bound parameters. The AST expression solver and variation point solver classes relevant to the derivation process can be found in the evaluation package. All these previously introduced systems are used when determining well-formedness. Due to it being impossible to check all variants for being well-formed, a different approach is taken. Some variants based on the variation tree structure are selected and checked. See the variation tree leaf paths class for more information on the variant selection process. Additionally, all cocos are run again on component instances. Let us now look at an example. Here we are looking at the household robot product line of iRobot. We can see that the core component is decomposed and has multiple features. A feature model is shown on the right. First, we will run MontiArc, which generates the corresponding symbol table, prints it to a file, and checks all the context conditions. No special settings have to be set when using variability. Now we can look at the resulting export and see the similarities. The export is a bit different to the symbol table internally, but we can see how the variation tree is included with all its symbols. For example, a smart robot with floor plan tracking has a map navigator, a camera on top, and an image processor, which all can be seen on the right. Now that you have seen how the tool works, I want to talk about some things left to be improved. In the future, the expression solver could be extended and improved to allow better variable handling. Compatibility with generics could also be established, and better IDE support for variability is also desired. Due to the design of checking the same context conditions multiple times, it can also occur that the same error is logged multiple times, which might be misleading to some developers. In the future, our system could also be extended to support dynamic software product lines, which would allow an architecture to change during runtime and adapt to an ever-changing environment. Thank you for watching my technical preview. I hope this gave you a good overview of the variable systems in MontiArc.